Hi everyone, welcome to Caltex Academy. Today we're looking at indefinite integral and specifically we're looking at just Trig substitution. So when you have a number just like on a board here, where we have the integral of 1 divided by under root of 1 minus x squared with respect to x, the moment you see minus here and another number just like 1 and x, it's very easy. You have to know that we have two options of substitution here. One is you can use cosine substitution or sine substitution. But of course we know that the derivative of sine is positive and the derivative of cosine will give you a negative. So I'll just go with a positive derivative. So you're free also to use cosine and be able to come up with a derivative which will be used for substitution here. So what is the first thing? We just look at this square term in this radical and we write it out as sine. Now we can change the variable from x to theta, so sine theta should be equals to x. Then let's differentiate each of these sides by respect to the letters we have. So from the left hand side with respect to theta and right hand side we have respect to x. So here the derivative of sine theta is cosine theta. So the first one here is cos theta with respect to theta, that is the theta, equals to, this is the x. Now after this we can make substitution to our work here. So how do you do that? Let's start with our solution just near here. So we can write our integral of 1 and the root of 1 minus x squared with respect to x can be written as, so here we're replacing x with sine theta and we have under root of 1 minus sine, but remember x has been squared, so we have to also square our theta, sine square theta. So we multiply this with the x, and now the x is cos theta d theta. Now again from this identity which says if you have cos square theta plus sine square theta is equals to 1. If we try making cos theta the subject, we'll have here cos square theta equals to 1 minus sine square theta. Getting roots on both sides to get something similar like what we have here, we have cos theta equals to the positive square root of 1 minus sine square theta. Based on this, we can recognize that, okay, under root of 1 minus sine square theta is just simply cos theta. And with this, we can move on and replace our denominator with cos theta. So we have 1 divided by cos theta, and we multiply this by our original cos theta, the theta. Now having written this, we'll notice that, okay, cos theta from the denominator and this one will cancel off, and we're only left with 1 that's going to be integrated with respect to theta. And here this is very easy. We have simplified it down in a way that when you integrate 1 with respect to theta, we'll just get theta. And since it is indefinite integral, then we can add the arbitrary constant. But now our question was in terms of x and our answer here is in terms of theta. So let's write back from theta to x. Now how do you do that? From our previous substitution here, we added and say sine theta should be equals to x. So for us to make this in terms of x, we can isolate theta and we get inverse of this. So we have sine of x. Or in some books, we realize that instead of writing this, we write arc sine of x the same way. So I'm taking the first approach here and then replace our work with it here. So finally, now instead of writing theta, we are writing our answer here in terms of sine inverse. So we have sine inverse of x plus our arbitrary constant. If you enjoy this video, please give it a thumbs up, subscribe to the channel and share this video with friends. Then we meet again in the next one. Ciao.